Welcome to another episode of Software Explorations, Concepts and Overviews, hosted by yours truly, Tech Coach Ralph, where, above all else, we are engineered to win. In today's episode, we are going to be taking a dive into the realm of DevSecOps. Yes, DevSecOps. Development, security, and operations. So, full disclosure, this was brought to my attention by my guy, another YouTuber, Ferris. Check out Ferris Doe on YouTube. He's in cybersecurity. He does a lot of cool stuff, learning Python and things like that. But he's the one who sent me the link about DevSecOps, and I said, let's do a deep dive in it, see what it's about, and get some more context. Because he's in cybersecurity, I'm in development and QA, and I also do things with Terraform and deployments and stuff like that. So it's like we're building our own team, our own network with his development mindset and my with his security mindset and my development mindset and my QA mindset and things like that. And we just come together, work together and stuff like that. So let's not waste any more time. Let's just jump right into what in the world is this DevSecOps thing that we talk about, right? So let's get to it. All right, DevSecOps. And let's get into an introduction about it, because I'm not too familiar with it as a whole. When I was creating this presentation, I see some parts of it that I am familiar with, but then there's some parts that I am not familiar with, some tools I'm not familiar with. So I wanted to go into an introduction for DevSecOps, and then maybe in the future we can do some deep dive. Maybe we can look into these tools that they use. Maybe we can do a simulcast with Ferris to see, because he's familiar with some of these tools. I'm familiar with some of the other tools, the languages, the coding, and see what we can come together with, right? Let's do some cool stuff, right? So let's get to it without any further ado. So our agenda for today, we're going to do an intro to DevSecOps. We're going to look at the key principles, the benefits of DevSecOps versus traditional security. How do we implement this? Some practices and techniques. We're going to talk about some challenges, and then we're going to wrap it up with our conclusion. And you know how we normally do. You know how we do on a Wednesday software explorations for concept and overviews. All right, let's go. All right, so what in the world is DevSecOps? So it's short for development, security, and operations. You might have heard the term DevOps before, where it would combine development and operations. There's DevOps engineers. They work on maybe the pipelines, on how to setting up the Git actions and all that stuff, where the developers are writing out the code. And then now there's the operations part about deploying it, testing environments and things like that. Now we're adding another component of security. So this is an approach to software development that integrates security practices within the DevOps process. It aims to ensure that security is a core component of every stage of the software development lifecycle, the SDLC, from initial design through the deployment and maintenance. Here are the key aspects of DevSecOps, and that's what we're going to get into, right? So, key principles, key aspects, key principles. Shift left mentality, automation, collaboration, continuous monitoring, security as code, compliance and governance, risk management. And here's the thing with this, right? Because me, by trade, by default, by heart, I am a QA engineer. And every single one of these things, except for security as code for the most part, is also part of QA. We have the shift left mentality. We've been talking about that for a while. How to get QA more involved at the beginning. And that's what we're going to see with security. Automation, a huge part in creating reliable software, collaborating with the stakeholders, the engineers, everyone. Continuous monitoring, that's why we have our automated scripts. Security, QA doesn't really think about that as much, but we should, because security is everybody's job. Compliance and governance, not as much as a QA part as well. Try to stay up to date, but it's not as much. And then risk management, QA is definitely involved in risk management. So what I'm seeing with all the things that we're putting together here, they all are looking to optimize the process and work more closely with the engineers so that we can have better quality code. We can have more secure code in applications, more deployable code in applications, more testable code. So that's why we have operations coming closer to the engineering, to development. We have security coming closer to development. We have QA coming closer to development at the beginning instead of towards the end, right? So to the left, what does it mean to shift left? So security practices and testing are moved earlier in the development process, often referred to as shifting left. Same thing for QA, same thing for operations. How can we write our code? For example, I'm going to give you a DevOps practice. Writing unit tests that they can be executed through the CI/CD pipeline so that you can have confidence and assurance that your code did not break any existing functionality or tests. Now, you can have bad tests, yes, but that is the concept, and bring it into that CI/CD pipeline, that's a DevOps. Now, automation tests like API tests, UI tests that are also running in the CI/CD pipeline, that's also shifting left. And now, how do we integrate security into that, right? So this means integrating security measures in the initial stages of development rather than addressing them at the end. How do you integrate security in the initial stages? So for me, it's let's talk about security. Let's talk about security, baby. What are the risks that can be associated? What are the libraries, the tools that we're planning on using? Are there any vulnerabilities? What is our plan to keep these libraries or packages or modules up to date so that we don't end up having a vulnerability? How often do we check this stuff? How are we planning to scan our repos? So this is like thinking about this at the beginning instead of after all the work is done. Now we're like, oh, we didn't see this coming. And we've seen so many episodes of the Bug Bite where companies got bit by a bug in their behind. Bit by a bug in their behind, all right? So security is bringing it earlier in the process is supposed to help us alleviate these fears and these vulnerabilities. Can you catch everything? No, but you can catch a lot more. Why do you spray your home for pests? You don't try to take care of the problem after the fact. You try to take care of it before it even happens, being proactive instead of reactive. And we'll get into that, right? Automation, one of my favorite topics. Automated security testing tools are integrated in the CI/CD pipeline, continuous integration and deployment, and continuous deployment. This includes tools for static code analysis, dynamic application security tests, DAST, and software composition analysis tools, SCA. All right. So the same way that we have automation for testing, for like our quality, functional API, component integration, we also have tools for security testing. And I am very, very interested to we have to do a live stream on this now on how can we integrate some security testing tools into our workflows, into our pipeline so that we can have some good analysis so that we know that our code is secure and that we're not going to get hacked and stuff like that. So collaboration, how does collaboration work with DevSecOps? So developers, security teams, and operation teams work closely together. This collaboration ensures that security is considered throughout the development and deployment process. Practically though, how would we do this? So my idea would be, I don't think that you would necessarily, unless it's a really, really big, really big project or application, maybe as Amazon's website, maybe you'd have security people embedded into a team full time. But I could see that you can have a security team, and then because they're not necessarily the ones writing the code, but they're making the recommendations, doing the scanning and stuff like that. And you can embed them into a couple of teams where they join the stand-ups and things like that. And they provide information, they provide feedback, they provide analysis. And that way they are right there with the developers instead of waiting until the whole application is done. And then they swoop in and say, oh, this is a problem here, this is a problem here, this is a problem here. Why can't we save more money, save more time, save more effort, get to market faster if we have them in at the beginning, it says, okay, these are the best practices that we're going to do. And the developer's like, okay, this is what I think I'm using. And they say, okay, have you considered this? Have you considered that? Oh, my recommendation is this. And we get that all out of the way in the beginning. So then we don't have to go back and rework a bunch of stuff. Because one thing that drives me crazy is after we write a bunch of code and then we find out that none of it works because of A, B, and C, and we have to go redo it. It might have worked on your machine, but for production, it's not going to be viable. So let's try to nip that in the bud via collaboration. What about continuous monitoring? What's that? I mean, it's exactly what the name says. So security is not a one-time activity, but a continuous process. We are at risk every single second of the day, every single millisecond. So we need to continuously monitor our systems to make sure that things are on the up and up, checking for vulnerabilities, for malware. For software engineers who decide to use sudo to push passwords to the repo, we need to check for that. Systems are continuously monitored for vulnerabilities, and feedback loops are established to address any issue that arises in real time. We need to catch that as early as possible. The longer something exists, the more risks that it brings to us. You know, it's like a sickness. For instance, unfortunately, if someone has cancer, the earlier you catch it, the faster you can treat it, and the better your chances are. But if you catch it very, very late, it makes it a lot tougher to recover, especially without any like lasting damage. Because let's say you like there's a breach in your system, and it takes you a very long time to catch it. You don't know how much damage, you don't know how much data is going to get out there. But if you catch it right away, you can just pluck them out, you know? So what about security as code? Security policies and practices are treated as code and integrated into development environments. This ensures consistency and repeatability of security measures. So, and that's basically, all right, instead of like having all these manual processes, like, oh, we have to go here and do this, to me, it would be like a Terraform for security, a Packer for security, whatever the DevOps people use for their deployments and stuff like that. We need the same thing for security. And towards the end, we'll jump into like some tools that are used for DevSecOps for the security part of it. Because we already know, well, I mean, you might not know watching this video for the first time, or if you're new to tech, but there are plenty of tools that we use to manage our code, to write our code, to write our test, to manage our deployments, to run our test in a pipeline and stuff like that. But what about security? You see me, I'm not familiar with the ones for security at all. So we're going to jump into that as well. So compliance and governance. DevSecOps ensures that compliance with regulatory requirements and industry standards are maintained or is maintained. Automated compliance checks and governance policies are integrated into the development pipeline. So, for an example, in GitHub, we have GitHub Actions, and they'll run these actions to, you know, so I have like at work, there's plenty of GitHub Actions, but for one of the projects I'm working on personally, I figured out how to create a GitHub action, and it's running some API tests or some unit tests. And the same way, we can integrate some compliance checks and some governance policies into these pipelines, because you want to make sure that you're following standards and you're not violating any regulations, so that your company doesn't get a lawsuit, a big fat lawsuit. We don't want that. So risk management. By incorporating security into the development process, DevSecOps helps in identifying and mitigating risk early and reducing the potential impact of security breaches. What are the benefits of DevSecOps? So like I was just mentioning, early detection. The earlier that you find it, the less exposure that you have, and the better off you're going to be. If it lingers around, it's going to really impact you. Enhanced collaboration. So it gets everyone working together, everyone on the same page early. Shift left. As opposed to all the work is done, as opposed to the waterfall model, right? All the work is done, and then you ship it over to QA, and QA does all of their work, and you ship it over to security, and now security's like, oh, well, there's this vulnerability. So now you got to go and patch a bunch of things, update things, fix. Then now you have issues because this package is newer and your code doesn't work with it. I've seen that in Node many times. And now you have to make a bunch of updates. So now you have to go back to QA. Then you have to go back to security. And now security finds something else. You know, that whole cycle. Enhanced collaboration. The earlier we can work together, the better off we're going to be. Which leads to us faster time to market. Time is money. You guys know me. Time is money. So the longer that you take to get to to the people, to the marketplace, that is the competition who is getting there before you and taking your customers from you, because it is like, especially for these big time applications, it is so hard. Like once a company gets locked in, especially a big company, they get locked into an application, it is hard for them to leave to another one. It costs them. It costs them. So they would rather have the company that they are with make enhancements for them instead of them having to leave. So if you are taking time, if you're taking a lot of time to get to market, now your competitions have better chances, right? Improve compliance and resilience, making your application bulletproof. All right. So how does DevSecOps compare to traditional security? So with traditional security, we have the sequential approach, siloed teams, manual processes, reactive security, and compliance focused, right? And we will dive into each of those, right? So what is a sequential approach? Like I was mentioning just now, waterfall method. Traditional security often follows a waterfall model where security testing and assessments are done at the very end of the development process. So all the code is done, all the work is done, ready to deploy, and now you give it to security and like, oh, well, there's a bunch of problems. The credit cards are like this, or what you're doing with customer data. So if we can start that conversation as early as possible, you don't have to worry about that. But that's part of the sequential approach. Security as a gate. Security is treated as a final gate with testing and review happening just before deployment, as opposed to at each step of the way. We know this is good, and then we have automated tests around it so that every time we make a change, we run the test. And like, okay, cool. I feel confident. We don't have to go and do a bunch of manual stuff over and over and over again. So what about the siloed teams? Isolated security teams. Security teams operate independently from the development and operation teams, often leading to communication gaps and delays. Limited collaboration. Minimal interaction between development, operations, and security teams can result in misunderstandings and overlooked security issues. And that's why you bring them together as early as possible, as with the enhanced collaboration. And then it's so manual. It is so manual. Manual reviews and testing. Security assessments and reviews are often manual, making them time-consuming and prone to human error. The more you do something manual, the more human error that you're going to get. And that's why I am an automation fanatic. Whatever I can automate, that's what I'm going to do, right? You also have delayed feedback. Security issues are identified late in the process, increasing the cost and complexity of remediation. Like I was saying, the earlier you catch it, the cheaper it's going to be for your company. It's like a bug in software testing. The further the bug gets from the development, the more expensive it is. Because if you have a bug and you catch it during development, it doesn't really cost you much. If you're able to prevent it from ever happening, it doesn't cost you anything. But if it gets all the way into production, and now it might be impacting customers, you might have to roll back, you might have to patch, so many different things. So now you have to stop working on things that were new to go back out there in production, fix some. Like I remember, like we've had to run some scripts to fix some client issues that we've created because we ended up rolling bugs to production. So the delayed feedback and stuff like that from security, it might be even be more riskier, because if someone gets a hold of that, you are, So what about reactive security? So post-deployment patching. Security vulnerabilities are often addressed reactively with patches applied after the software has been deployed. Incident response. Focus is on responding to security incidents rather than preventing them. So I believe in proactive. That's why when I'm doing QA, I start planning how I'm going to. I start planning from the very first time that the story is created, and what are the risks? What does the acceptance criteria say? Are there any questions that I need to know so that we can figure these things out? And then I start writing my test plan as early as possible so that I can have a discussion with the developer so that we can make sure we're on the same page. So when we receive the actual application to start testing, I even start writing my automation while the developers are still working on the code, so that once it gets to me, we're like, okay, boom, let's just run these tests. Let's do a little bit of manual testing, but we all know what we're looking for at that point. And that's the same thing with the being proactive in your security approach, as opposed to what this is saying here, being reactive. Compliance focused, right? So this is for the type of security where you're just focused on compliance. So you have these periodic audits, they might be, twice a year, 4 times a year. So they're compliance checks that are done periodically rather than continuously, which can lead to gaps in security posture. So if let's say we check some security, we do some security audit today, and then the next time we come do it is in like 3 months down the road. How do we know that everything is safe between today and 3 months down the road? And that's where it gets a little murky, right? Checklist mentality, emphasis on meeting compliance checklists rather than holistic security practices. So thinking about security as a whole is way better than say, okay, got this done, got this done, got this done, got this done, and now let's go on. But now, what if there's this other thing we're not even considering, and now that totally messes us up, right? So what about the DevSecOps model? So with DevSecOps, we have an integrated approach, that collaborative culture that we spoke about. Automation can't live without automation, the proactive security, and the holistic compliance. So the integrated approach, continuous integration built into our CI/CD pipeline. Security is integrated into every stage of the software development lifecycle, from planning, design, deployment, and maintenance. Security as code. Security practices are codified and automated within the CI/CD pipeline, ensuring continuous security checks. So every time you push something to the branch, you should have your security checks running, and you should also have on a schedule, like through your CI/CD software, to run these checks. Maybe whatever your team decides. It might be on a nightly basis, it might be on an hourly basis, whatever you decide. So what about the collaborative culture of DevSecOps? Unified teams, very, very important. Developers, security professionals, and operation teams work together, fostering a culture of shared responsibility for security. Everybody owns security. It's not just on one person. Just like everyone owns testing, everyone owns development, everyone owns deployment, everyone owns cost saving. Enhanced communication. Regular interaction and collaboration between teams reduce misunderstandings and ensure security is prioritized throughout the process. Now, automation. Automated tests. Security testing tools such as SAST, DAST, and SCA are integrated into the CI/CD pipeline, enabling continuous and automated security assessments. You also get immediate feedback with that. So automated tools provide real-time feedback to developers, allowing for quick identification and remediation of vulnerabilities. So also proactive security. Of course, we've mentioned this, shift left to the left to the left. You must not know about security, right? Security is shifted left in the development process, meaning vulnerabilities are identified and addressed early, reducing the cost and complexity of fixes, which leads to continuous monitoring. Systems are continuously monitored for vulnerabilities and threats, enabling proactive security measures. And now, holistic compliance, continuous compliance. Compliance checks are integrated into the development pipeline, ensuring continuous adherence to regulatory requirements. So you just code your regulatory requirements. Beyond checklists, focus is on building secure and resilient systems rather than just meeting compliance checklists. Which checklists, they're not going to catch everything, and you're just going to be so focused on the checklist, and you're not focused on the actual security of the software. Now, how do you implement DevSecOps? So we're going to go a very, very high level of this, but you have to, first and foremost, you have to foster the culture. You have to put security into the mind of the developers and the operation team so that they can become one unit, one team. Integrate security into the development lifecycle. So that's like as you are writing your stories, as you are developing, as you are testing, as you are deploying, security has to be in all aspects of that. Automate your security testing. Goes without saying. Implement continuous monitoring and feedback. So something, a loop, a feedback cycle that's going to let you know that things are passing, or hey, as soon as there's something critical that comes in, you get alerted and you have to check that out. Adopt security as code. Code your security so that you don't have to, you can just run it and now you're not prone to development errors or human errors. More implementation. Enforce a strong identity and access management policy. Make sure people are who they are and they are where they're supposed to be. Conduct regular security audits and compliance checks. Develop an incident response plan. Measure and improve. So I was trying to figure something out yesterday for one of the apps I'm developing and deploying, and I was about to get complicated, and I say to myself over and over, make it work, then make it better, make it work, then make it better. Because sometimes you want to just do a little bit more, like, oh, I wonder if I could do it like this, right? But you know the way that it's going to work, and you can always go back and make it better. So I'm like, I said to myself, I said, you're on a time crunch, make it work and make it better. Make it work and then make it better, right? So measure and improve. Always looking for improvement. See where your stats are, how things are looking, and then make it better. And then the tools and technologies to implement it. So there's a bunch of different tools and technologies. All right, so for foster a DevSecOps culture, promote collaboration, break down silos between development, security, and operations, encourage open communication and shared responsibility for security. So bring everybody together. Bring them all together, allow them to work on the same team and share their opinions and their thoughts and their expertise freely. Training and awareness. Provide training for all team members on security best practices and DevSecOps principles. Ensure that everyone understands the importance of security in the development process. Security into the development lifecycle. So how do we bake this into the development lifecycle? So first and foremost, as we've said many times already, shift left. Integrate security practices early into the software development lifecycle. This means incorporating in the planning, design, and coding phases. Threat modeling. Conduct threat modeling during the design phase to identify potential security risk and design mitigation early. So now, how do we automate our security testing? So CI/CD pipeline. Integrate security testing into our CI/CD pipeline to enable continuous security checks. So static application security testing. Automatically scan source code for vulnerabilities during the build process. So every time you're going to make a new build, you're going to scan the source code. Dynamic application security testing. Test running applications for security issues during the testing phase. So we should have tests that are designed for security as well. And then software composition analysis, scan for vulnerabilities in open source and third-party components. And this is the part that a lot of people miss, because open source stuff and third-party stuff, you are so subject to vulnerabilities and stuff like that. And that's why a lot of these platforms, they have a check to make sure, like, hey, you are 3 versions back. You should upgrade. All right. So what about continuous monitoring and feedback? You implement tools to continuously monitor your applications and infrastructure for security and vulnerability threats. So if you get a red flag, you have to stop the presses. Hey, we have to address this. Which also gives you real-time feedback, which provides immediate feedback to developers on security issues found during automated testing. Now, adopting security as code. Infrastructure as code. Tools like Terraform, AWS CloudFormation are used to manage provision infrastructure securely. Ensure that security configurations are codified and version controlled. Policy as a code. Implement security policies as code to automate compliance checks and enforce security standards consistently. The key word here is consistently. Everything has to be done consistently, on a schedule, on a regular basis, so that, and it shouldn't be like months apart from one another. It should be regularly, so that if something new does come in, you're able to catch it. And enforce a strong identity and access management process. So least privilege principle. Remember when we spoke about zero trust architecture? Ensure that users and services have the minimum level of access necessary to perform their functions. Multi-factor authentication. How many times have we seen people been bit by by not enabling multi-factor authentication? That's exactly what happened to Snowflake, amongst others, right? Implement MFA for accessing critical systems and sensitive data. Role-based access control. Use role-based access control to manage permissions and restrict access based on user roles. Now, what about our security audits? Automated compliance integrates compliance checks into the CI/CD pipeline, ensuring adherence to regulatory requirements and industry standards. Regular audits. Perform regular security audits and penetration testing to identify and address potential vulnerabilities. Now, what about the incident response plan? Incident response teams establish a dedicated incident response team with clear roles and responsibilities. So that's setting up your team. What are the response procedures? Develop and document incident response procedures, including detection, containment, eradication, and recovery steps. And then you do regular drills. Conduct regular incident response drills to ensure that the team is prepared to handle security incidents effectively. All right. So how do you measure and improve your DevSecOps process, right? So metrics and KPIs, key performance indicators. Define key performance indicators and metrics to measure the effectiveness of your DevSecOps practices. Examples include the number of vulnerabilities detected and remediated, mean time to resolution for security issues, and compliance status. And I'll say that should be applied to all types of issues, right? But you would segment them between quality issues and security issues. So continuous improvement. Regularly review and refine your DevSecOps process based on metrics, feedback, and security and evolving security threats. So it has to be based on data. It can't be based on how you feel. Everything has to be based on data. So what are some tools and technologies that we use for DevSecOps? So the version control tools, Git, GitLab, GitHub, what's the other one? Bitbucket, things like that. So what are the CI/CD tools? Jenkins, CircleCI, Travis CI, GitLab, CI/CD. Even GitHub Actions should be in there, right? And then what are the SAST tools? That would be SonarQube, Checkmarks, Fortify, and then the DAST tools would be OWASP, Zap, and Burp Suite. And then the SEA tools, Dependabot, Sync, Whitesource. And you know, we're gonna look into that to see how we can integrate each one of these into our apps so that it can be more safe, more secure for us. All right. So tools and technologies. Container security would be Aqua Security, Twistlock, Claire, and then monitoring tools would be Prometheus, Grafana. We have installed Grafana before, ELK Stack, and Splunk. We've spoken about Splunk. And then infrastructure as code, we have Terraform, AWS CloudFormation, and Ansible. We're going to be getting into Ansible once we are done with our Terraform course, and then we're going to go into DevOps, which is going to include Ansible. But what are some challenges to DevSecOps? So this is always going to, these challenges are going to be across industries, right? But there's going to be some cultural resistance. There'll be some cultural resistance because if it's not something that you are accustomed to, you're going to be like, oh, why are we doing this? This is more work and stuff like that. But for me, I always see it as, okay, it's for the good of the application and good of the company and to protect our customers. So, but there's always going to be cultural resistance. And there's going to be a skill gap because not everybody is very familiar with these cybersecurity words and how to do it, the tools that they use. So it's going to be a learning curve. There's going to be integration complexity working with people who are not traditionally in your department. The automation challenge, I figure out how to actually use these tools to automate these processes, or what's the code base, things like that. Then you're going to have to balance the speed that you work at and your security. It's very similar to writing test-driven development, where with test-driven development, people think at the beginning they go slow, but in the long run, if you compare where they are a year later versus somebody who is not using TDD, it's going like you're going to see two very, very different code bases, and one of them is going to burn out. I'll let you decide which one. So the same thing for integrating DevSecOps into this, right? So continuous monitoring and incidents response, because like it's gonna take people being on call, working overnight, or being on call overnight, being on call on the weekends, just to make sure that things are going correctly, and and then compliance and regulatory challenges. So always making sure that you're up to date and that you're in compliance with whatever regulations are being set, that you're staying up to date. You have the new context, and then managing legacy systems. Legacy systems are one of the worst things to work on because it's a lot of bad code, doesn't have much testing, and then trying to see how can we integrate these new practices into this old code. A lot of times companies just say, you're just going to start writing the code over again. And then measurement and metrics, trying to figure out what you want to measure, what metrics you want to follow are going to be another challenging aspect. All right, so that is our presentation for today. We spoke about what DevSecOps is, the key principles of it, the benefits of DevSecOps, and how does DevSecOps line up against traditional security models, how to implement DevSecOps, and we will do some live streaming on that at some point in the future on how that works. The best practices and techniques, the challenges that you face when implementing DevSecOps, and then if you have any questions, please leave it in the chat. I will make sure to respond to you and find an answer to your question. All right. So with that being said, we're going to go back to full screen, and that is it. Let me know your thoughts on it. Did you like it? Did I do it justice? Anything that's lacking? Anything that we should add to it? Whatever the case may be, I am more than willing to do a follow up, and we are definitely going to go live about this at some point. But just want to say thank you guys so much for tuning in to another episode of Software Explorations, Concept and Overviews, hosted by your shooty tech coach, Ralph. If you haven't done so yet, do me a big favor. Go over to www.techcoachralph.dev, where you can sign up for exclusive content. And you can sign up for one-on-one coaching with me, where we can work together. I can give you the blueprint on what you need to do, monitor you closely, be your accountability partner, work on your resumes, work on your interview preparation, maybe even get you on working on a project to build some experience, whatever the case may be. But that is the plan. That is where we're headed. And before you head out, do me a big favor. Like the video, share the video, subscribe to the channel, hit the notification bell so you know every single time that we go live or drop new content. But on that note, you guys have a wonderful Wednesday afternoon. This is Tech Coach Ralph, and we are out.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.